Hello, hi everyone. Today I'm going to talk about the ASNs and engineering program that the community colleges have. I'm just going to briefly go through who I am. I'll go through the differences between science and engineering so you can get an idea what engineering encompasses. I'll go through the different fields that you may want to study in engineering, and then I will talk about how you can what courses you need to take and how you can take the ASNs and transfer to UH Manoa to get your bachelor's in engineering. So who am I? I am a physics and science instructor at Kauaʻi Community College. I also work for for a grant, an HOH grant, which is an environmental science grant. I have a degree in physics. I worked as an engineer for about 4 years, and then I went into teaching. Here's all the places I've lived and worked. As you can see, I'm Canadian, so I've never lived in mainland USA, but I've worked in Canada and then moved here to Hawaii. If you want to get a hold of me, my email is below. So my engineering experience, I started with a master's in physics. I then spent 4 years working for 2 companies, the pressure pipe inspection company and Hashmont McDonald. So I worked inspecting pipelines using AC, alternating current, and electromagnetic waves. So this is kind of a bunch of different fields. It was a civil engineering field, but it required electrical engineering as well, and we billed ourselves as being environmental. After working in engineering, I studied education in physics and mathematics, and I learned how to teach in some remote communities. I went and taught high school math and physics in the Arctic in Canada, and then I moved here to Kauaʻi to teach at the community college. So I wanted to go through the difference between science and engineering because it can be a bit of confusion, and likely if you're coming from high school, you've only actually had science classes. So on the left-hand side, I've got science, and on the right-hand side, I've got engineering. I've got a picture of a guy here in a microscope. So in science, we experiment and we try to find research things about the world which we don't know. So we're trying to find new fundamental information and increase the understanding that the human race has of the world around us. In engineering, the little differences are we design things. So we come up with designs of any kind of thing. Could be a structure, could be a cell phone, could be a car, and then we build them. So we're using things for society. We're applying science knowledge to build things to increase the function of society. So they can be very interrelated. So engineers will need to use the information that scientists find out to design and build new and better things. But as engineers build things, they may need to experiment with them to make sure they are acceptable. So making sure that a bridge won't collapse, or making sure that anything they build will work properly. So there can be some benefits to each of them. This is more political and career-wise. If you study engineering, I'll go through engineering first. Job prospects, if you take a 4-year degree, if you do 2 years at a community college, 2 years at Manoa, you would have very good job prospects. Civil engineers are needed everywhere. I always recommend people take civil engineering, especially if they're from a smaller town. If you're from Kauaʻi, then you would have jobs here, building roads, bridges, everything. A great thing about science and engineering, both of them actually are relatively high-paying jobs, and the job satisfaction, people are quite satisfied. They can be challenging, interesting jobs. So the high pay and high job satisfaction, that happens in science as well, but typically engineers have one of the highest of those categories. The benefit of science, you could have more freedom, not working for a company but a university. We would call it academic freedom. So what exactly you want to study, you'll have more freedom in that, and there also can be more freedom not always being 9 to 5. The other big advantage is if you want to study past your 4th year bachelor's degree and get a master's or a PhD, if you do that in a science such as biochem or physics, the core sciences, you'll get fully funded for the most part, which means you'll probably get your tuition paid for, and you'll also be given maybe depending on the school, 18 to 20,000, 18 to 30, 40,000 a year in cash to study and to live on. So I'll go through, there's three major fields of engineering that I like to, this is kind of how I look at it and how you should look at it as you're approaching it as a new student. There's civil, which is building bridges and roads and the like. There's then, electrical, I put that third there. Electrical engineering, which deals a lot more with microchips and electricity, and then mechanical engineering, which deals with moving parts. So you could think of cars and wheels and bearings. So I'll start with civil. So there's a lot of jobs in civil engineering. So you can kind of get a job anywhere. If you're from a smaller town, this is a really good one to go into. It's also known as the easiest of the engineering fields. So when you're going through and studying, it has some of the less difficult mathematics, and it also has the most jobs. So in a lot of ways, I always recommend this is the best one. You're going to get a job, it's not the most difficult, and you're going to get paid just as well. It also, if you're a civil engineer, you may get into environmental engineering or construction engineering. So environmental and construction engineering, they have their own fields. You could take environmental engineering, but then you wouldn't be qualified as a civil engineer. You could take civil engineering and you would be qualified to work in environmental engineering. So it's a more broad field. If you take it, you have a lot of options. Usually you work for something called an EPCM, or Engineering Construction Procurement Management Firm. I just put down here pictures of all the things you do, kind of designing, making blueprints. You could be making blueprints. You could be helping construction guys read them. You could be talking about what things need to be built in the field. So you could be working in an office, but you also could be working out in the field on a construction site. Just going to depend on where your skills are or what you want to do. So there is a lot of flexibility when you work for companies. I also put down here kind of windmills and pipelines, so things that relate more to the environment. If you're digging up pipelines all the time, then you can be damaging the environment more. Or if you have leaks in the pipeline, you could be leaking oil or water. Even water, you can create sinkholes and damage things. It's going to damage the environment and cost cities more money. I also really believe in there's a lot of benefit to having local engineers. So when you bring in people from somewhere else, they often don't necessarily know exactly what the local environment has to hold. I know there were some really big windmills in my hometown. They brought them in and they were too big. They don't necessarily turn. So they spent millions of dollars paying someone from another area to bring in windmills. And I think here in Hawaii, what I see often is poor HVAC design. So HVAC stands for heating, ventilation, and air conditioning. So if you build a solid concrete structure, you're not going to have the airflow underneath. So if you look at some of the more traditional designs of free-flowing air and kind of having the ability to have air go underneath the building, whether it's a plantation style or just not a concrete structure that they build over on the mainland, people come here with this idea, I'm going to put a solid foundation down, and then it doesn't allow the airflow. It traps humidity inside. It makes mold grow, and they come here, they don't know that because they're not local. So if you have local engineers building things, they're going to build them more appropriate for the environment. So electrical engineering, there's jobs for electrical engineers everywhere, but it's not necessarily as widespread. We've got an army base here on Kauaʻi that they require electrical engineers. I know some that work there. And then also, if you look at things like electrical power transmission, so down, in the bottom corner here, these guys could be civil engineers or they could be electrical engineers. So there's some crossover. So usually an engineering firm is a civil engineering firm is not just going to have civil engineers for the building. They're going to have electrical engineers because all these buildings and things have electrical controls in them as well. Electrical engineering is more difficult. I called it challenging here, but there's still a lot of job prospects. There's also a lot of private companies designing all kinds of different devices. So You could be designing microchips and computers. You could be designing individual components for the microchips. This is a transistor, so these are the little components that make up microchips, which make up computers. You could be designing, you know, crazy devices here for moving fingers and arms. And then there's also optical, you know, interpreting optical signals. So fiber optic cables transmit data, and then from there they have to change them into electrical signals that can be interpreted. So there's tons of things, but a lot of these more interesting things you'll have to go to bigger cities for. I'm sure Honolulu has a few companies, but California's got probably the most in the world. So if you want to go to California and do something, some kind of interesting devices, electrical engineering could be for you. Final one I'll go through is a mechanical. So mechanical engineering, I really like it, but the reality is that there's not a lot of jobs. Everybody puts a computer in things nowadays. You know, cars are fired by distributor caps and computer control. They got rid of the carburetor. They always make things extra complicated. I don't think they should, but they always put computers in everything. Mechanical engineering is the hardest, and there's the least job prospects because really everyone's looking at having a lot of electrical engineers. So typically a mechanical engineer is going to have to also study electrical and put them together. Yeah, I don't know why there's not more on this. Things you'd be working on, you know, cars, you can be a helicopter or airplane mechanic, farm equipment, military devices. They've got a lot of mechanical, anything with moving parts where you're building things. There's also a lot of different, so those are the three major fields. There's also a lot of different specialty types of engineering. So I don't think you should be worrying about these right away. The problem with specialty types of engineering, you know, mining engineering is part of civil engineering. So if you're a mining engineer, you can't be a civil engineer. But if you're a civil engineer, you can be a mining engineer. Same with oil. If you're an oil pipeline engineer, well, that's all you can do. If you're a mining engineer, you can still do oil engineering. Or if you're civil, you can do both. There are some more interesting ones like biomedical and computer. So computer engineering is a whole field on its own, which I'm not really going to talk about today. Building computers and designing computer programs, I'm not going to get into that. So these four specific fields you can all get at Manoa. But I really think you should be thinking about, at this point, because you're just going into engineering, which of the major fields you really want to go into. Okay, so let's take a look at the requirements. So there's a lot of math required. You may be able to start with calculus if you can qualify. So you need to first off figure out, do I qualify for 241? Have you taken 103 or 140? So each of these, if you take 103, then you can get into 140. If you take 140, you can get into 241, and so on, and so on. So you can also you can potentially start here if you've taken the appropriate high school classes, or if you take a college placement test, you can get right into that. So this is the hardest part of the engineering, is getting through the math, because they're structured in such a way that you need 6 of them in your first 2 years. You also need to be, you need to take Math 241 to get into Physics 170, and Math 242 to get into Physics 272. So it's really important signing up for engineering that you really make sure you enroll, you start right away to get math classes, because there's so many of them and they're all structured. If you don't take math in your first semester, you don't get this one, and then you aren't able to move into the next one for the next term, so then you lose a whole year. So make sure you start math, talk to your counselor, and research on your own. Take a look at this, these program sheets here. And then you will need to get through both the physics courses, which are connected. Depending on the campus you're on, you may be able to take this math and this physics at the same time, but some campuses require you to take this one first and then take the physics class. I allow students to take the physics class at the same time as they're taking the first calculus. So these are all, again, these are all calculus classes, and these are the 2 classes you need to get into calculus if you don't have the required math skills. There's also talk that 240, so the final 2 classes, you can take this class instead. Instead of these 2 math classes, you can take just this one. It's not confirmed yet. Yeah, I don't know. It's not official, but word of mouth is you can. I'm going to briefly go through, if you wanted to take a look at the program sheets, you'd click on this link here. So the program sheets, and you can see requirements. So I brought up 3 requirements here. Here's our civil engineering, our electrical engineering, and I took a specialty one, a biomedical. And you can see highlighted in yellow, that's your first year. They're all the same. They're all the same. So it doesn't matter which one you go into, you're going to be taking the same classes in your first year. Other than, I think, the civil is an ICS, this OR, so they don't have that. So if you took all the electrical classes in the first year, you could still go into civil. You could go into biomedical too. And then in green, I've shown you the other sequence of calculus classes you require. It's the same calculus, same physics classes. And then in the gray are other courses that are part of our community college program. So all of these courses that are outlined, you'd be taking at the community college. And when you transfer over to Manoa, you'd be taking all the ones that aren't highlighted. So this is the ASNS. So you'd be looking at Kauaʻi Community Colleges calls it the ASNS in engineering or pre-engineering. I'm sorry that there's 2 words for the same thing. So some of the other community colleges should have a very similar program. So you take this program and you get the requirements for the first 2 years of most of the engineering programs. Like I said, you may miss if you want to go special, like the biomedical. You may not. We offer this course in Kauaʻi, and it's required, but it's not part of our engineering program because this is a specialty. This is a specialty program. There's also physiology, which we offer here, but it's not part of our program because this is a specialty engineering. It's not one of the 3 major types. So you can take the ASNS in engineering. The ASNS in physical science is also very similar. So if you took this, you would only be missing 2 calculus classes, but the rest of the coursework would be the same. So you would be able to still become an engineer if you took this. So if you click this link here, you'd be able to take a look at the requirements that we have for our ASNS engineering program. Okay, so here's our ASNS program requirements. You just click here, and it brings up a list of all the courses that you're required to take. So we've got our engineering, our math, our chemistry. You still need chemistry. It's got math in all of them, and it's got physics here. We've organized it a little differently than Manoa has, but you'd still get 60 credits that you need towards your engineering degree. I want to go back and click on this link. Okay, so this is where I go to look at all the program info for the engineering. So if we go to the College of Engineering, so the program, so here's our civil, electrical, mechanical, and then the specialty ones. So if you look at the program sheet, it'll give you exactly what you need. The plan templates are the one I've shown you, where it's going to give you the spreadsheet and show you the semester. So just click on these. Okay, so here's all our requirements. So there's the math requirements, all 4 of the calculus. There's your 2 physics requirements. You've also got some chemistry. And there's other, you need English, other ones. So all of these college requirements here are all met by our ASNS program. And if I click on the plan template, and then you go here, and there it brings up the same sheet that I had in the presentation. So again, if anyone wants to get a hold of me to talk, I'll talk to you guys on an individual basis if you need help. Try to figure out what field's right for you. If you're trying to figure out how you can organize your schedule to get into an engineering program, feel free to shoot me an email. We can schedule a time to meet. We can do it via Zoom, phone call. We can chat on Discord or whatever. Let me know. I'm here for you guys. Okay, so I'll take any questions.
Thank you. That was a great presentation with a lot of good information. We thank everyone for coming.